good. If you want that your preparation should be the best, you need to be ready. If you are ready, type down in the comment box you are ready, and we will start the session. I don't know what's happening, but yes, some problem is there. My video is getting stuck. Yes, video is lagging. My voice is clear or not? At least my voice is clear. Can you please confirm that my voice is clear or not? Can you please confirm my voice is clear? Very good evening, very good evening. अरे लैगिंग का लैग जो है खत्म कर देंगे आप लोग. प्लीज कंफर्म कीजिए माय वॉइस इज क्लियर और नॉट. Yes, always ready. Chaliye. Okay, so if you guys are ready, let's start the session now. Okay, so let's talk about lower triangular matrix. For that, to have the lower triangular matrix, we should first have originally n cross n square matrix. पहले हमारे पास होना चाहिए n cross n का square matrix. So here I have taken an example of 4 cross 4. So this is the example of 4 cross 4 original matrix. Now what is lower triangular matrix? The lower triangular matrix says that the original diagonal, this one, and below elements are present, remaining elements all 0. The lower triangular has some elements, remaining elements are 0. तो जो इस triangle में element दिख रहे हैं, whichever the element you can see in this particular triangle, all those elements are non-zero. Actually, the element which are of our interest, and remaining these are all zeros. ये 0, ये 0, ये 0, ये 0, ये 0, this 0. All these are 0, 0, 0, 0. Now, see, the thing is, if you are having a lower triangular matrix and suppose I am starting lower bound of row and column from 1 1 for some kind of convenience I have taken these. Okay, some kind of convenience I have taken these 0 0 0 or a starting index is 1 and 1 for row and also column also. Fine. Now look at this. If we are having a lower triangular matrix like this, starting index for row and column 1 1, can you tell me outside triangle element should be 0? Yes or no? Yes. If these elements are 0, then should we store these elements? क्या हमें इन एलिमेंट को स्टोर करने की जरूरत है? Should we store these elements in the memory? Answer should be no. Why not? Just because we will efficiently utilize our memory, and for that, if we already know that this element should be 0 only, why should I store it? Whenever CPU wants, or whenever somebody asks me what is the element A of 1 2, can you please fetch it from the memory? I will tell, I don't have to fetch my memory. I can directly say ये element 0 होगा, this element will be 0 only. Similarly, if somebody asks me what should be the element 2 4, A of 2 4, I'll say 0. How can I say that? This element is outside my triangle, and outside my triangle all the elements are 0. So I don't have to even store these elements. मुझे store करने की जरूरत ही नहीं है. I can directly say कि these elements which are outside, all these elements should be 0 always. Always, yes, always. That is the definition of lower triangular matrix. So should I store all these zeros? No, I should not have any place for those zeros. Now I will simply write a condition. Condition is what? Condition is for which element I can directly say. For which element I can directly say that the element is 0. I will say, if suppose somebody is asking me some condition is true, then I can say A of I comma j is equal to 0, and for that the condition is very simple, I less than j. I less than j. Yes, Nishu, great. So I less than j, you can see this, I less than j, I less than j, I less than j, 2 less than 3, 2 less than 4, 3 less than 4. If I less than j, then a of ij is equal to 0. Else, in else case what? A of ij I will store non-zero. If not equals to 0, fine, I will store these elements only. Store these elements only. Hope you guys are understanding. समझ आ रहा है कुछ? घुस रहा है यहाँ पे के ऊपर से गया? So these elements only I am storing. Now you will have to tell me how many stored elements. Stored elements. What is the number of stored elements? How many number of elements you are going to store? This one. From first row, only one element included, which is gonna be stored. Then from second row, 2. From third row, 3. Similarly, from fourth row, 4. If we will be having a generalized case n cross n, can I say from first row 1 element stored, plus second row 2 elements are stored, from third row 3 elements are stored, such kind of you are having n number of rows, then last nth row will have n number of elements. Total how many number of elements stored? n into n plus 1 divided by 2. अब ये मत पूछना ये कहां से आया है. Yes Mr. Jain, exactly first n numbers का yes summation, perfectly correct. So if you understood stored elements are n into n plus 1 by 2, you can put the value, n equals to 4 रख के देखो क्या आ रहा है, n equals to 4 रख के देखो क्या आ रहा है, n equals to 4 if you will be putting here 4 into 5 divided by 2, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements you are going to store. 1, 2, 3, 4, 5, 6 elements you will not store. 10 elements you will store, 6 elements you will not store. Why? Just because 6 elements are 0. Got it? Perfectly fine. If you are done with this, let's go and let's try to understand how this lower triangular matrix will be stored in the memory. So let's talk about row measure order. So there are two types of storage we can have of lower triangular matrix itself. What are the two different types of storage? Row measure and column measure. Okay, so row measure, you know that row wise you will have to store. Column measure means column wise you will have to store. First let's see row measure order. चलिए देख लेते हैं row measure order क्या बोलता है. ओह जी का आगे. Fine. So this is the lower triangular. I'll have to store this in the memory. Fine. Now I'll have to store it in row measure order. Let's do that. First of all, first row. From the first row you have only one element A11. That's it. Then A11. That's it. Second row is having two elements, A of 21 and A of 22. Second row done. Then third row is having three elements, A of 31, 32, 33. And last row will have four elements, 41, 42, 43, 44. That's good. Understood? Fine. If you remember my previous lectures, I have always told you one thing, which is relative index. Relative index means before any element in the memory, how many elements are stored. Before any element in the memory, how many elements are stored of that array. So if I'll check out A of 1, 1, the relative index of A of 1, 1 should be 0. Why? Just because before this no any element of the array is stored. A of 2, 1 is having relative index 1. A of 2, 2 should have relative index 2. Why? Just because two elements are stored before A of 2, 2. For A of 3, 1, relative index 3, here 4, for this one 5, for this one 6, for this one 7, for this one 8, and this one 9. Simple. Easy. Why this relative index is used, I will tell you just now before we go for a location formula or something. Let's assume that each element takes 2 memory locations and the array base address is, in the memory array base address is 200. Array base address 200 and each element takes 2 locations. So this element should have 200 address, next element should have address 202, just because each element taking 2 location. Then 204, 206, 208, 210, 212, 214, 216 and 218. These are the elements. If I am saying just calculate A of 43's address, for A of 43, somehow you will have to get this relative index 8. If you get relative index 8 into what is the size of each element? 2 into 8, 16 plus base address will be the address of this particular element A of 43. The problem is only how do we get this relative index 8, and that is what we are going to learn now. We means you, मुझे आता है, तुमको सिखाने का है बस. चलो देखो, how do we get the location in row measure order? First of all, we will go with the basic. Row measure order में कैसे मिलता है location? So if location of an element A of ij is asked, see, you can write like that way also, or you can write that square bracket notation also, doesn't matter. It's just the representation. We are not learning any programming language, so we don't have any problem. First of all, base plus W into, in the row measure order, what is the formula? Formula is number of elements from lower bound of row. Row number is starting from 1 to I minus 1 rows plus j minus lower bound of j. That is the basic formula we have for this. Now look at this. Why I have written this? ये लिखा क्यों है मैंने? ये देखो यहाँ पे. See, look at this. If suppose I am saying this is my ith row and this is my jth column, I'll have to first reach to ith row. Before reaching to ith row up to I minus 1 rows, all the rows I have stored. Yes, starting from 1. Here the row number starts from 1. So 1, 2, 3, 4 up to I minus 1 row, all the elements you have stored. Yes, now within jth column, before reaching to jth column, within this ith row, before reaching to jth column, some more elements you have stored. Yes, that's why I have written j minus lower bound of j. Right? Let's calculate now that how many number of elements are there from row number 1 to I minus 1 row. Fine. So I am writing here number of elements in first row. How many elements are there in first row which you are storing? कितना एलिमेंट था फर्स्ट रो में जो आप स्टोर कर रहा है? आंसर इज 1. अरे ओ सांबा, रो नंबर 1 में कितना एलिमेंट था रे? सरदार 1. आप भी तो एक ही. चलिए नेक्स्ट. In the second row, how many elements are there? 2. Third row, 3. Fourth row, 4. I minus 1th row, how many elements? I minus 1. First row में 1. Second row में number of elements in second row is equal to 2. Then how many elements should be there in ith row? I minus first row. I want to check for I minus first row. Why? क्योंकि वहीं तक मुझे चाहिए, ith रो के अंदर के एलिमेंट तो अभी नहीं चाहिए. I माइनस फर्स्ट रो में आएंगे I माइनस वन एलिमेंट अभी. If that is the case, then total फर्स्ट रो, सेकेंड रो, थर्ड रो, फोर्थ रो, I माइनस वन रो, सारे रो को आपको स्टोर करने का है. फर्स्ट stored, second stored, third stored, yes, fourth stored, up to I minus one row stored. Yes, why? Just because I am checking out ith row का element. So before ith row, 1 to I minus 1 rows all are stored. Yes, how many elements total in those? How many elements total in those from first to I minus 1 th row? Number of elements from row number 1 to I minus 1 टोटल कितना हो जाएगा? गुड निशु, नाइस. एडिशन ऑफ ऑल दिस, फर्स्ट में 1 प्लस सेकेंड में 2 प्लस थर्ड में 3 प्लस I minus 1 तक हो I minus 1. Add these values 1 to I minus 1, I minus 1 into I minus 1 plus 1, which is I divided by 2. This is the number of elements from row number 1 to I minus 1, which I will place here. So my formula will become base address plus W into I minus 1 divided by 2 plus J minus lower bound of J. J माइनस लोअर बाउंड ऑफ J. अभी J माइनस लोअर बाउंड ऑफ J कितना होगा? J तो J है, ठीक है, J तो J ही रहेगा. अभी लोअर बाउंड कितना होगा? लोअर बाउंड देख लेते हैं हर एक रो के लिए. J का लोअर बाउंड कितना आ रहा है? लेट्स चेक इट आउट. Let's check it out. For each ith row, what is the lower bound of column number? We have 4 rows here. Oh. Can you tell me, for first row, this one, which element is the first element? Which column number is the first element? Column number 1. यहाँ पे for the second row, which element is the first element of the column? 1. Third row, which element is the first column number element? 1. Fourth row, 1. So can I say for every row the lower bound of J is 1 only? Yes. So for each row we are having lower bound of J 1, 1, 1, 1. We can place that value 1 here, J minus 1. This is my final formula. Final formula. LB of J is equal to 1. बढ़िया, अरे बहुत सही, शानदार, अमेजिंग अमेजिंग. आई जस्ट वांट दैट यू गाइज लर्न. आपको बस सीखना है. अगर आप सीख जाएंगे मेरा आज का लेक्चर सफल हो जाएगा. इसको एक बार वेरीफाई करके देख लेते हैं. लेट्स टेक एन एग्जाम्पल. Let's take an example. If I want to calculate LOC A of 4,3, I am just interested in the second part of formula, this inside the bracket. If it can give me 4,3, if it can give me 8 as the relative index, my work is done. The remaining thing is as it is 0. Remaining thing is as it is 0. W is how many spaces each element takes. Each element takes how many? Right? Now listen. Let's try to calculate. Let's try to calculate 4,3. A of 4,3. I is 4. J is 3. Let's use this one only. Base plus W into I, which is 4 into 3 divided by 2 plus J 3 minus 1. 6 plus 2, 8. Yes, we are correct. Look at this, we are correct. Index, relative index 8. Each element if takes 2 space in the memory, 2 into 8, 16 plus base address. My work is done. मेरा काम खत्म हो गया, मेरा वर्क खत्म हो गया. Understood that? Now listen, now listen, now listen, now listen. See, this particular example I have made when we were having a of this array starting index from 1. If you have from 0, what are the changes you will have to do? What are the changes you will have to do? Number of elements you will have to count from 0th row, then 1, then 2, then 3 up to I minus 1 row. Like this way you will have to calculate. See, if 0 is the first row number, 0th row में 1 element, first row में 2 elements, second row में 3 element, like this you do your own. आप एक homework के जैसा इस question को लीजिए और solve कीजिए. Do it by yourself. If 0th row is having 1 element, first row is having 2 element, I minus first row will have how many elements? Addition of those minus j minus lower bound of j. Lower bound of j will become 0 at that case. In that case. Right, so what exactly right now I have taken lower bound of row and column I have taken for 1 so that you can understand the concept. Once you understand the concept, you can change the concept, you can apply the concept for any lower bound. Whichever the lower bound you have, for that you can apply the concept easily. कोई भी आप आराम से आंसर ला पाओगे. I hope that's clear to you guys. Now let's go further and let's try to understand its lower triangular matrix column measure order. This is little bit different and difficult also. Not too difficult if you have a good mathematics, grip, but it will be slightly different and difficult than the previous one. Let's understand. Same lower triangular matrix? Yes, same lower triangular matrix. This samosa बना दिया मैंने, ये लो. Lower triangular matrix. Now this lower triangular matrix I'll have to store in column measure order. Same to same. Let's store in the column measure order. If you are storing in column measure order, how do you store? A of 1 1, A of 2 1, A of 3 1, and A of 4 1. First column done. Second column starts from this A of 2 2. A of 2 2, 3 2, and 4 2. Then third column A of 3 3, 4 3, and last column will have only one element 4 4. That's it. I don't know, some problem is there in the camera, because of that my video getting stuck. If audio is fine, please keep doing this particular, keep learning. Okay, keep learning. Element stored column wise. Okay, I did that. Let's have the relative indexes 0 1 2 3 4 5 6 7 8 and 9. Now let's try to understand its same formula which we have done here. So for column measure order, what is the basic formula of the location? So the basic general formula for column measure order is this. If I want to get the location of A of ij, first of all you are storing the columns. If you are storing the columns, suppose this is the jth column, this is ith row, what I'll have to do is, before reaching to jth column, you are storing all the columns up to j minus 1. You are storing all the columns up to j minus 1. From which column number? First column number. Why first column number? Just because I told you that the first number in the column is 1. The lower bound of column number is 1 basically, right? So what I am writing is, basic formula is same to same, base plus w into number of elements in columns from I to j minus 1, or sorry, 1 to j minus 1. So from column number 1 to column number j minus 1, total elements you count, plus I minus lower bound of I. That is the basic formula. Okay. How many number of elements in columns from 1 to j minus 1? How many? चलिए देखते हैं. सबसे पहले the very first thing we're gonna get is number of elements in first column. Let's check out how many elements are there in the first column. How many elements are there in the first column? क्या बात है, लोग अब टीचर्स को भी चेक करने लगे कि सर आप ठीक ठाक हो या नहीं. अरे भैया हम यूट्यूब के चैट रीड करते हैं. How many elements? How many elements in the first column? 4. But if we have in the generalized scenario n cross n matrix, how many elements we are going to store in the first column? Oh, row major order tak aa gaya main. In the first column, how many elements? How many elements we are storing in the first column? The total 4, which is nothing but n. Can you verify this? Number of elements in the first column is equal to n. First column number of elements stored is equal to n. Right? Now I am asking second question. Number of elements in the second column, how many? In the second column, how many elements you are storing? 3, which can be n minus 1. Can be n minus 1. So number of elements in the third column should be how many? N by n minus 2. Directly I can write n minus 2. क्या बोलते हो? Fine. So number of elements jth column will have is equal to how many? If j is equal to 1, n minus 0, right? If j is equal to 2, n minus 1. If j is equal to 3, n minus 2. If j is equal to j, how many elements? Can I say this one? J plus 1 or j minus 1? J minus 1 here. J is equal to 1, 1 minus 1, 0, n minus 0. J equals to 2, 2 minus 1 is 1, n minus 1. J equals to 3, j minus 3. Or sorry, 3 minus 1 is 2, n minus 2. N minus j minus 1, or you can say n minus j plus 1 outside. But do we require the elements up to jth column or up to j minus 1 column only? कहां तक required है? Do we require the element up to jth column or j minus first column? J minus first column. J minus first column. हाँ जी, ठीक है. Okay, fine. तो how many number of elements should be there up to j minus 1th column, or in the j minus first column? In j minus first column, how many elements are there? J की जगह j minus 1 रख दो, it becomes n minus j minus 2. n minus j minus 2. So in first column n minus 0, second column n minus 2, a third column n minus second column n minus 1, third column n minus 2, in J minus first column n minus J minus 2. Total how many? Total from first to J minus 1, how many? I am writing here. Total elements from column number 1 to J minus 1 is equal to how many? Add all these, सबको ऐड करने का n minus 0 plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4 plus n minus J minus 2. Fine? Is that fine? अभी इक्वेशन सॉल्व नहीं किया बॉस, इक्वेशन सॉल्व नहीं किया हूं, जस्ट आई हैव रिटन फर्स्ट कॉलम n minus 0 एलिमेंट्स प्लस सेकेंड कॉलम n minus 1 एलिमेंट, थर्ड कॉलम n minus 2 एलिमेंट्स अप टू j minus फर्स्ट कॉलम n minus j minus 2 एलिमेंट्स. नाउ I will only ask you, let's do one thing. To solve this particular equation, what I am doing is I am adding first n. सिर्फ n को टर्म्स को ऐड करो, n plus n plus n plus n plus n plus n plus n. How many times n we have? From 0 to j minus 2. 0 to j minus 2 means j minus 1 times n I am having. Only add n. jth वाला ऐड नहीं करेंगे, g नहीं करेंगे, बिल्कुल नहीं करेंगे. ये तो मैंने सिर्फ ऐसे ही लिख दिया था बाबू, इसको हटा देते हैं. इसकी जरूरत नहीं थी, वो सिर्फ इक्वेशन लिखने के लिए थी कि ये jth अगर होता तो क्या होता और j minus 1 है तो क्या होगा, इसलिए वो लिखा था. See, look at this. My actual requirement is I need the elements from column number 1 to j minus 1. In column number 1 we have elements n minus 0, column number 2 I have element n minus 1, column number 3 I am having elements n minus 2, up to column j minus 1 we are having number of elements n minus j minus 2. I want all these elements. Yes, take the summation. We have taken the summation. Yes, what we do in that summation, just add n. How many times n we have? N minus 0, n minus 1, n minus 2 up to n minus j minus 2. I can say 0 to j minus 2, total j minus 1 times n we have. So if total j minus 1 times n we have, then it becomes j minus 1 times n minus this minus common. In the bracket we will be having 0 plus, why plus? Just because minus I have taken common, plus 1 plus 2 plus 3 plus 4 up to j minus 2. All these will be in the other addition. Now can you give me the solution of this one? कितना आएगा ये? Exactly n minus n into j minus 1 as it is, minus 0 plus 1 plus 2 plus 3 plus 4 plus up to j minus 2. Summation of first j minus 2 elements or natural numbers, it will be j minus 2 into j minus 2 plus 1, which is j minus 1. So let's write that j minus 1 first. J minus 1 into j minus 2 divided by 2. These many number of elements should be there from column number 1 to j minus 1. Can you please verify? Can you please verify? Till now everything is clear. So I am writing that formula, n into j minus 1 minus j minus 1 into j minus 2 divided by 2. Plus I minus lower bound of I. Here there is a twist. there is a twist. What is the twist? Look at this, look at this, look at this. Twist क्या है और क्यों है दोनों समझाएंगे. पहले twist क्या है समझते हैं, फिर क्यों है समझेंगे. For each column I'll have to understand what is the lower bound of I. Look at this. If I am asking this one, when j is equal to 1, so we can have 4 columns, column number 1, 2, 3 and 4. Okay, let's see column number 1. Column number 1, this one. Can you tell me which row element is the first one? Which row is included as the first element? First, row number 1. Row number 1? Yes. In this column, column number 2, do we have row number 1 element included? No. So which row number is the first element? Row number 2. For column number 3, the very first element is row number 3 ka element. For column number 4, fourth element. Right? So lower bound of I, for j equals to 1, lower bound of I is 1. For j equals to 2, lower bound is 2. J equals to 3, lower bound is 3. J equals to 4, lower bound is 4. Means lower bound is changing along with your j value. Yeah, got it? That is why here I'll have to write lower bound of I is equal to what? Is it 1 always? No, it's not 1 always, it's j. If j equals to 1, lower bound of I is j. 1. If j equals to 2, lower bound is 2. J equals to 3, lower bound of I is 3. J equals to 4, lower bound of I is 4. You know why such kind of case? Why such kind of case? I'll check it out here. Look at this. Look at this. I'll tell you here. Suppose मैंने आपको दिया, पैसा वैसा नहीं दे रहा हूं मैं. Look at this. I have given you this column number 4. Column number 4. Fine. You have already calculated before column number 4. First 3 columns are stored. In those columns, how many elements you stored? Yes, you calculated. Yes, you calculated with this particular formula. बड़ा सा formula हमने mathematically calculate कर लिया. Yes. Now in this column number 4, if I am saying row number 4, can you tell me within this column before row number 4, any element you have stored? Any of these elements you have stored? No. So after calculating this plus I minus lower bound, I minus lower bound says that ki how many elements within this column you have before reaching to your intended element. So if you say row number 4, before row number 4, in this particular column I don't have any element. If row number 4 is given, in this particular column I don't have any element. That is why I will subtract 4 minus its lower bound, column's lower bound. Column is 4, then lower bound is 4, no element 0. But look at this. If row number is 4 given here, for j equals to 3, then 4 minus lower bound 3. 4 minus 3, one element is stored in this particular row. आप देख सकते हो. Getting this point? So we need to calculate actual number of elements within that row and within that column. That is why we are writing that lower bound different than 1 always. Let's just check it out. Let's take a simple example. Let's calculate location of A of 4, 3 here. Or let's say 3, 3 here. Fine. Let's take it out. I is equal to 3. J is equal to 3. My major motive is this remaining formula. So it's base plus W into n value 4 cross 4 matrix into j minus 1. J is 3. 3 minus 1 is 2. minus j, 3 minus 1, 2 into 3 minus 2, 1 divided by 2 plus I, 3 minus 3, 8 minus 1 plus 0, 7 I am getting. Is there any mistake we are doing? We are getting 7 for 3 3, for 3 3 7. Yes, we are correct. We are correct. For 3 3 it is 7. Can you confirm? Can you confirm, is that correct for everybody? Can everybody confirm, is that fine for everybody? Is that fine? If that is fine, we are going to go for the next one. So column measure order, this is done. Formula we have already calculated. Yes. Now upper triangular matrix, just opposite of whatever we did last time. ज्यादा टाइम नहीं लगाएंगे इसमें, बड़ी ही आसानी से हो जाएगा ये, बहुत आसानी से हो जाएगा ये। कितना आसानी से? जिस आसानी से आप एक आइसक्रीम चट कर जाते हो ना, उतनी आसानी से। Now let's see what happens. Let's see what happens. Upper triangular matrix. Upper triangular matrix says that if you have this, okay, आइसक्रीम की जगह मोमोज ले लो यार, जो आपको पसंद है वो ले लो। This one, main diagonal and above main diagonal, all the elements are non-zero, remaining all zeros. Remaining all zeros, right? So if somebody says that, can you give me the value of a of 2 1, we will say yes, it's 0. How can you say it is 0 just because it is outside my triangle? How can you detect that this is outside my triangle? It's very simple thing. When I is greater than j, you can see I is greater than j, I greater than j, I greater than j, greater than j, greater than j, greater than j. Simple. Yes, right? So what am I saying is this: I will write a simple condition. If I is greater than j, for that particular case, a of I comma j is equal to 0, else a of ij is equal to non-zero. When a of ij non-zero, these elements only I will store. मेरे को non-zero से ही मतलब है. These elements are only stored. Can you tell me how many elements you stored actually? If you have originally n cross n matrix, if you have originally n cross n का square matrix in the general, how many elements actually you are storing? Number of elements stored. From the first column you are taking 1, from the second column you are taking 2, from third column you are taking 3 elements, from the nth column you are taking n number of elements, sum of first n natural numbers. Good, Nishu. n into n plus 1 by 2, Raj. Number of elements stored, n into n plus 1 by 2, not minus. Fine. Now let's try to quickly check out its row measure order. देखिए, the row measure order here will act exactly same as the previous one's column measure order, and the column measure order here will exactly give you the answer same as row measure order of the previous one. So I will just give you the quick solution so that you will not waste your time, we will not waste your time which is more precious for your exam. आपको ऐसा लग रहा है कि बहुत टाइम बचा हुआ है, बट बहुत टाइम नहीं बचा हुआ है. You have very less time, very less time, and that particular time we need to utilize. चलिए तो स्टार्ट करते हैं. कॉलम row measure order, row wise we will have to store the elements. Okay, directly I am going to draw this samosa, bread samosa. ये ले. This you will have to store row wise. First of all, entire first row A11, A12, A13 and A14. Next, second row starts from 2 2, then 2 3, then 2 4. Similarly, A of 3 3, 3 4, third row, fourth row only single element 4 4. Okay, now these are the relative indexes. Relative indexes. If we have relative indexes like this way, let's just check out the row measure order ka formula. So if you want to get the location of A of ij, what should be the formula for row measure order? The formula is very simple: base plus w. W is size of each location or each element in the memory. Number of elements from row number 1 to I minus 1 plus j minus lower bound of j. Basic formula, yes, done. Let's try to calculate how many elements are there from row number 1 to row number I minus 1. Let's quickly take it out. Fine. So, how many number of elements are there in the first row? Number of elements in first row is equal to n. How can I say? Look at this n. Second row n minus 1, third row n minus 2. So number of elements in the second row will be equal to n minus 1. Number of elements in the third row will be equal to n minus 2. अगर ऐसा है तो how many number of elements should be there in the I minus 1 row? Answer will be n minus I minus 2. Now just add all these values. How many number of elements from row number 1 to this I minus 1 is equal to how much? It will be n minus 0 plus n minus 1 plus n minus 2 up to n minus I minus 2. Now let's add all these values. If you add all these values, it becomes n we have I minus 1 times minus 0 plus 1 plus 2 up to n I minus 2, which becomes I minus 1 into I minus 2 divided by 2. Good, Nishu. Let's put these values here. So it is I minus 1 times n minus I minus 1 into I minus 2 divided by 2 plus j minus lower bound of j that we will have to calculate separately. And this will be same as the previous column measure order, twisted wala. For each row I will have to have lower bound of j. For row number 1, 2, 3, 4. Look at this. Row number 1, column number starts from 1. Row number 2, column number starts from 2. Row number 3, column number starts from 3. Row number 4, column number starts from 4. बिल्कुल सही समझे, बिल्कुल सही समझे. आई की जगह जे, जे की जगह आई लिख दो, सेम टू सेम फॉर्मूला आपको बन जाएगा. कॉलम का रो, रो का कॉलम, ये हो जाएगा आपका फॉर्मूला. Similarly, now I would like to leave the remaining thing for column measure order for you guys. प्रैक्टिस लेक्चर्स चाहिए. प्रैक्टिस लेक्चर्स वहां मिलेंगे जहां आपको जरूरत है. एरे के ज्यादा क्वेश्चंस आते नहीं है प्रैक्टिस के, तो इसलिए मैंने रखे नहीं है. आपको लिंक लिस्ट में डीपीपी जरूर रखूंगा मैं. जैसे ही लिंक लिस्ट फिनिश हो जाएगा वो हम जरूर रखेंगे. ठीक है, डेफिनेटली आई विल टेक इट. तो ये हो गया आपका कॉलम मेजर ऑर्डर. कॉलम मेजर ऑर्डर, हाउ द एलिमेंट्स आर स्टोर्ड कॉलम वाइज. तो आप अगर लोअर ट्राइंगुलर, it's not lower triangular, upper triangular. Upper triangular CMO. So if this is the upper triangular you wanna store, in the column measure, first column, first element only, second column 1, 2 and 2, 2 elements only, third column 3 elements, 1, 3, 2, 3, 3, 3. Next fourth column 1, 4, 2, 4, 3, 4, 4, 4. Yep. Okay, so if these are the elements, what will be the formula for upper triangular matrix ka CMO? This will work same as the row measure order of the previous one. Yes, so I will write down the location of A of I comma j is equal to base plus W into number of elements from column number 1 to j minus 1 plus I minus lower bound of I. And here the formula you will be having is base plus W into number of elements from column number 1 to j minus 1 will be 1 plus 2 plus 3 plus up to j minus 1, which is j into j minus 1 divided by 2 minus I minus lower bound of I will become 1 for each and every column. How can I say that? Look at this. For this column, row number 1 is 1. For this column, starting row is 1. For this column also, starting row is 1. For this column also, starting row is 1. So this particular formula will be your final one. Done. Once, if you want this particular thing, you can do like that way so that you can have a practice. And one more thing I would like you to do is, if the first row and first column number is 0, what will be the formula? Now you can change if you understood exactly how this particular method work. अगर आपको यहाँ तक समझ में आया है तो starting indexes of row and column if starts with 0, then how these formulas will work or behave or change, you can easily understand. Of course you will be able to do. Now based on these formulas, I would like you to solve these questions. These questions, 2 questions you have, upper triangular matrix you are storing. So this one is lower triangular matrix, row measure. This is upper triangular matrix, row measure. You will have to calculate the answers, that which is the actual location when I have given W also, base also. Use the formula, get the answer. These quizzes are your practice questions. I am giving you as homework tomorrow before